Take a look at this reaction. Do you think it happens through SN1, SN2, E1, or E2? Up to now, we've been looking at a reactant and a set of conditions and asked to come up with a product, and we learned how to do that. But sometimes your professor will give you a reactant, conditions, and the product, and ask you to come up with intermediates or the complete step-by-step mechanism. In fact, this question came from an exam where over 100 students failed to get full credit. The first thing we want to figure out is if this reaction happened as a substitution or elimination. We'll start with a 4-part checklist, pretending we don't see the product to figure out what's going to take place, and then I'll show you a trick for using the product to come up with a reaction. Looking at the 4-part checklist, we'll start by looking at the alkyl chain, specifically the carbon holding the leaving group, to help us determine what kind of reaction can take place. Here I see an alcohol sitting on a secondary carbon. A secondary carbon can both form a carbocation and undergo a direct attack, so it doesn't tell me anything. All reactions can happen, SN1, SN2, E1, or E2. Next we look at the attacker. Typically you see it at the top of the reaction arrow, but H2SO4 is an acid catalyst. In fact, if you see H2SO4, immediately think dissociates in solution, gives me an H+. H+ is positive. It's not a nucleophile, it's not a base, it's not the attacker. But if all I have is ETOH, what is my attacker? This has to be a solvolysis reaction, where the solvent is both the solution and the attacker. What can I tell about ETOH? It's neutral. That means it's weak, and it's not strong enough to do a direct attack. Instead, it has to wait for a carbocation to form. If the attacker is weak, we are looking at a one-type reaction. That means we rule out SN2 or E2 because ETOH is not strong enough for a direct attack. Which will it be, substitution or elimination? We don't know. They're both in competition, so let's hold that thought. Next, we have the solvent, which we already said is ETOH. We know that an alcohol is a polar protic solvent, which will be very happy for a one-type reaction because it can stabilize the intermediates, and it will also prefer elimination over substitution in a two-type reaction. We've already ruled out SN2, E2, so it'll be SN1 or E1. And finally, we have the leaving group, which, wait a minute, OH coming off would be OH-. That is an absolutely terrible leaving group. What do you do with a terrible leaving group? You bribe it. You bribe it with an acid catalyst to protonate, as we'll see in the mechanism, turning it into a good leaving group. So all we need to consider is bribe. Typically when you bribe it, it will leave on its own, giving you a carbocation intermediate, which once again tells us the SN1 or E1 route. If you were not given the product, your answer would be both substitution and elimination, based on the checklist, and they both can occur. However, in this reaction, we're actually given a product, and here's the trick. If the product has a pi bond, you know that it did elimination. If the product does not have a pi bond, elimination did not take place. For substitution, we're looking for the attacker sitting on the molecule. ETOH has an ethyl group, which is a 2-carbon chain with an alcohol. In an SN1 reaction, the hydrogen gets removed. So we're looking at the solvent minus 1 hydrogen sitting on the molecule, and here we have the solvent minus a hydrogen. That O with a 2-carbon chain is an OET, telling us we substituted the initial alcohol for the OET group as an SN1 reaction.